In this video, we're going to review adding and subtracting like rational numbers. Now, I'm calling them rational numbers because they are fractions and mixed numbers and they're negative. Normally, when you talk about adding and subtracting like fractions, you're talking about just fractions and you don't have to deal with the negatives or the mixed numbers. So, all of these things are done the same way. I can call them fractions, I can call them rational numbers. For us, they are pretty much the same thing at our level. So for number one, we are going to add, because there's an addition sign. Remember, when adding and subtracting, you always want an addition sign. We're going to add negative 7/8 plus negative 3/8. Now, since the denominators are the same, we are allowed to just add the numerators. Because remember, when adding and subtracting fractions, and now rational numbers, when the denominators are the same, you can just add the numerators because we have, and I'm going to ignore the negative for a second, we have 3 out of 8, we have 7 out of 8 and 3 out of 8. So your total would then be 11 out of 8. The reason being, for our numerators, we have a negative 7 and a negative 3. When the signs are the same, if you think of tiles, if you have 7 negative tiles and then 3 more negative tiles, that gives you 10 negative tiles total. And then your denominator stays the same. So you wind up with a negative 10/8. But this problem needs to be in simplest form. We need to be able to simplify this down to a mixed number and then reduce it so that it is in simplest form. You can do either way. You can reduce first or you can simplify first. It does not matter. And I'm going to choose to simplify. That means I'm going to have 10 divided by 8. 8 goes into 10 one whole time, and 8 times 1 is 8. You subtract to get 2. Now, I am at the ones place, and when you're doing fractions or rational numbers, once you hit the ones place, you can stop. It's one of the benefits of fractions. So when I do this problem, the 1 is my whole number. And then I go down, the 2 will be my numerator, and then the 8, my denominator, stays the same. So my answer is a 1 and 2/8. 1 and 2/8. Don't forget that since this number was negative, this number is negative. I also want to point out that it is important that when you are doing these problems to start learning what algebra procedures look like. You want to have good math habits. The answer to this addition should have gone right under the addition sign, and when you simplify and reduce, the answers keep going straight down. Now, if I want to reduce my fraction, they're both even numbers. I can reduce 2 and 8 by 2. 2 divided by 2 is 1, 8 divided by 2 is 4, and then the whole number, the integer, negative 1, stays in front. Since the original problem here was negative, our answer is negative. And negative 1 and 1/4 is our final answer to this addition problem. Let's do another example. So once again, if the denominators are the same, then we can ignore them and just deal with the numerators. We have a positive 3 and a negative 11. And as long as we have a plus sign, we can follow the addition rules that say if you have 3 positive tiles and 11 negative tiles, they are different from each other. They will cancel out because of zero-sum pairs. All we have to know is that it's 11 minus 3 is 8. Our denominator 12 stays the same. And since there were 11 negative tiles, since there's more negatives than there are positives, our answer is going to be negative. Now, this is already a proper fraction. The smaller number is already on top, but this can reduce. Now, once again, they're both even, so I could reduce by 2, but I should always check to see if I can reduce more. And if I check, I can. I can reduce by 4. 8 divided by 4 goes in evenly, 12 divided by 4 goes in evenly, and if 4 works, I should check 8. 8 divided by 8 goes in evenly, but 12 divided by 8 is not evenly, so the 8 was not a good choice. We're going to go back to the divide by 4. 8 divided by 4 is 2, 12 divided by 4 is 3, and you'll notice that when I'm simplifying over here and when I'm reducing, I don't pay attention to the negative, but I don't forget about it either. I do my math the way I would with normal fractions, and then I just remember that since the problem was negative, my answer needs to be negative. Then I box in my final answer. All right, we're going to do one more problem, which is slightly different, because whenever adding and subtracting, you want to have a plus sign when there are negatives involved, and we do not have a plus sign. So we are going to do keep, change, which basically says that the first number before our sign we keep. Negative 2 and 3/16 is still negative 2 and 3/16. We will change our subtraction sign to an addition sign because we always want an addition sign when there are negatives involved. And we will change, and I'm going to ignore the fraction part, we're going to change the -5 to its inverse, and the inverse of -5 is +5. The inverse is always going to be the opposite sign. And then the 11/16 just follows. Now that we have a plus sign, we can now focus on adding our problems. When I say adding, I mean because there's a plus sign. But I do need to look at the signs. The left one is negative, and the right one is positive. The signs are different. The tiles will be different. They will cancel each other out. But once fractions are involved, I'm not really going to start drawing tiles because that would get confusing. I'm just going to go by the rules that I learned from the integer tiles. Since the signs are different, we're going to subtract. I also need you to notice the 5 is on the right. It's bigger. When we subtract, we are going to subtract the opposite direction that we are used to because you're always doing the bigger number minus the smaller number when ignoring the signs. That's called absolute value. Well, kind of for us. So you're going to do the numerators first. 11 minus 3, because the signs are different, is 8. Your denominator, 16, stays the same. But then you must do the whole number part, or the integer part. And 5 minus 2 is 3. And because the 5 is larger than 2, and 5 has a positive sign, the 3 will be positive. Once we're done, I need to make sure my fraction is not improper. It's not. 8 is smaller, and it's on top. And I need to see if I can reduce. When reducing, you should always check 2, 3, and 5. It just so happens, for all the ones we're doing, 2 already works. And looking at 8, 3, and 5 won't. So I check for 2 and it works. And remember what I said last time. If 2 works, you should check 4. And 8 divided by 4 and 16 divided by 4, it does work. And if 4 works, I'm just going to check 8. And this time, 8 divided by 8 is 1. And I can't go bigger than 8, so I know I'm done. And 16 divided by 8 is 2, which means I can reduce that fraction. And then the integer, or the whole number, can come straight down. And now that our fraction is simplified and reduced, we're done. Things I need you to remember when adding and subtracting like rational numbers, or like fractions, if you want, as long as you realize we have positive and negative numbers. When adding and subtracting them, if there are negatives involved, you always want to have a plus sign. Number 1 and 2 were fine. They already had a plus sign. Problem number 3 did not have a plus sign, and that's why we did the keep, change, so that we had a plus sign. Because once you have an addition sign, the rules are much simpler. If the signs are the same, you will add them and keep the sign. If the signs are different, you will subtract them and keep the sign of the one with the larger absolute value. You don't have to think of it that way if you want. You can just take the sign of the one that's bigger, the one that would have more tiles. And the better we get at this, eventually you'll start thinking of it as absolute value once you get better with the terminology. Thank you.